welcome back. The time has finally come to decorate our delicious-looking donut with sprinkles. This is usually the moment where the donuts start to get really fun. Sprinkles are purely decorative, but they give the donut personality. To build this, we're going to use one of Blender's most powerful systems, geometry nodes. Geometry nodes let us generate and control geometry procedurally instead of placing every object by hand. That means we can manage the number of sprinkles, their placement, their scale, and their randomness, all from one clean, flexible setup. And just so you know, this is exactly how production environments handle scattered detail like grass, debris, or crowd elements. No one is manually placing thousands of objects. This is real-world workflow. Alright, let's get started. Go up to the Workspace tabs at the top of Blender and switch to Geometry Nodes. If you don't see it immediately, click and drag across the tabs with the middle mouse button to scroll sideways until it appears. Then select it. On the left side, you'll see the Spreadsheet panel. We won't need that for this setup. Right-click between the editors, choose Join Areas, and collapse that panel. This gives us more room for the node graph, which we're definitely going to need. Now select the icing object on your donut. If it's off-screen, press the tilde key and choose View Selected to frame it in the viewport. With the icing selected, click New in the Geometry Nodes panel. This adds a Geometry Nodes modifier to the object and creates a basic node tree. On the left, the Group Input node represents the original icing geometry. On the right, the Group Output node represents the final result. Right now, nothing changes in the viewport, and that's completely normal. There's no operation happening between those two nodes yet. Our job is to build a system between them that generates controlled surface detail. Alright, let's start placing sprinkles. Before anything can sit on the glaze, Blender needs a way to determine where objects should be placed, and that starts with points. Think of points as tiny invisible pins distributed across the surface of the icing. Later, each one of those pins will become a sprinkle. Press Shift-A to open the Add menu. Go to Points and choose Distribute Points on Faces. Now insert this node between the Group Input and the Group Output. When you hover over the connection line, you'll see it highlight slightly. Click to drop the node into the link automatically. And now, you'll notice something unexpected. The icing disappears, and all you see are points. That's because Blender is currently outputting only the points. It assumes that's all you want to see. But we don't want to replace the mesh. We want to add to it. So let's fix that. Press Shift-A again and add a Join Geometry node. Place it after the Distribute Points node. Now take the original geometry output from the Group Input node and plug it into the Join Geometry node as well. And there we go. The icing mesh is visible again, and the points remain on the surface. Perfect. Now we have a clean procedural foundation, ready to turn those points into sprinkles. Right now though, those points don't exist in the render. They're just placeholders, data points in the system. To make them visible, we need to instance real geometry on top of them, in our case, sprinkles. So let's build the sprinkle models first. Switch over to the Layout workspace for a moment. Whenever you add a new object in Blender, it appears at the location of the 3D cursor. So let's move the cursor off to the side. Hold Shift right-click and place it somewhere to the left. If you're not using a mouse, you can activate the cursor tool. It does the same thing. Alright, press Shift-A, go to Mesh, and add a cylinder. Immediately reduce the vertices to around 12. We want these to stay lightweight. Set the radius to about 0.02 and the depth to 0.04. Now move the sprinkle upward slightly so it sits above the Z-plane. Frame it up close. Press the tilde key and choose View Selected. If you zoom in and the object disappears, that just means it's very small and the viewport is clipping it. To fix that, press N to open the side panel. Go to the View tab and lower the Clip Start value. That should make it visible again. Just double check yours. Mine looks good. Enter Edit Mode. Scale the sprinkle slightly along the Z-axis to elongate it a bit. This will be our short sprinkle. Right now the edges are sharp, almost like a tiny metal pin. Real sprinkles have soft, rounded ends, so let's clean that up. Switch to Face Select mode. Select the bottom face, then Shift select the top face. Press Ctrl B to bevel. Scroll your mouse wheel to add a few segments. And just like that, we've got smooth, rounded tips. Much better. Alright, we have our first sprinkle. But real sprinkles aren't identical. Variation is what makes them believable. So let's duplicate it. Press Shift D, then press X to move it along the X-axis. This will be our medium sprinkle. Enter Edit Mode, turn on Wireframe, and switch to Vertex Select. Select the top vertices, press G, then Z, and move them upwards slightly. If proportional editing is enabled, turn it off for now. Good. Duplicate it again. Shift D, move it along X. This will be the long sprinkle. Go into Wireframe, select the top vertices, press G, then Z, and extend it a bit more. Nice. Now let's add something less perfect, because in real life, sprinkles aren't perfectly straight. Duplicate one more time and move it along the X-axis. With this one selected, enter Edit Mode, press Ctrl-R to add a loop cut. Scroll the wheel until the faces are more evenly distributed, then Confirm. Go to the Modifier panel, add a modifier, and choose Simple Deform. Change the mode from Twist to Bend. Set the angle to around 60 degrees. If the bend looks off, it's usually because of the object origin. So select all the sprinkles, right-click, and choose Set Origin, Origin to Geometry. That aligns everything properly. Now apply the modifier on the bent sprinkle. And there we go. Short, medium, long, bent. They're subtle differences, but together they add a lot of realism. Before we move on, let's organize the scene. It might feel like housekeeping, but keeping things clean makes everything easier later. Go to the outliner and create a new collection. Rename it Sprinkles. Select all the sprinkle objects, press M, and move them into the Sprinkles collection. One more thing, the shading looks a little faceted. Select the sprinkles, right-click, and choose Shade Smooth. There we go. Clean geometry, nice variation. Ready to be scattered. Alright, back to the node setup. Select the icing again. If the Geometry Nodes editor switches away when you click another object, click the pin icon at the top of the editor. That locks the node tree so it stays visible no matter what you select. Now give yourself a little breathing room in the graph. Just drag the nodes apart so we have space to build between them. Next, we need to tell Geometry Nodes which sprinkles to use. Go to the outliner, grab the Sprinkles collection, and drag it directly into the Geometry Nodes editor. When you release it, Blender automatically creates a Collection Info node. Perfect. Press Shift-A, go to Instances, and add Instance on Points. Place it between Distribute Points on Faces and Join Geometry. Now connect the geometry output of the Collection Info node into the instance input of Instance on Points. You'll see them appear immediately. Make sure all three collection checkboxes are enabled inside the Collection Info node. As soon as that's active, the sprinkles scatter across the icing. Nice. Now press Shift-A again, go to Instances, and add Realize Instances. Place it between Instance on Points and Join Geometry. This converts the instanced sprinkles into real geometry, which gives us more control later. Now increase the density value in the Distribute Points on Faces node. Higher density, more sprinkles. But you'll notice they begin overlapping. That's because the distribution method is currently set to random. Change the distribution type from random to Poisson disk. Poisson disk spacing maintains a minimum distance between points. Now adjust distance min. If the value is too small, the sprinkles intersect. Our sprinkles are tiny, so we can push density fairly high. Slowly increase distance min while watching the surface until the intersections disappear. There we go. Clean spacing, natural scatter, no collisions. Now look at the sprinkles. They're all standing straight up. That's not how sprinkles behave. They settle onto the glaze. So let's correct the orientation. Go to Distribute Points on Faces. Drag the rotation output into the rotation input of Instance on Points. Now the instances inherit the surface orientation. Better, but our original sprinkle models were built upright, so we need to rotate the actual sprinkle objects. Select all the sprinkle objects in the scene. Press OR, then X, type 90 and press Enter. Now apply that rotation. Press Ctrl-A and choose Apply Rotation. Much better. Now they rest naturally on the icing. Next, rotation variation. Uniform rotation always looks artificial. Press Shift-A, go to Instances, and add Rotate Instances. Place it between Instance on Points and Realize Instances. In the Rotate Instances node, enable Local Space. That's important. Each sprinkle should rotate relative to itself. Now drag from the rotation input and add a random value node. For the maximum values, set Z to 2 pi, set Y to 2 pi. You can type tau, Blender understands it. For X, set the max to 0.5. This gives full rotation along the surface with a slight tilt variation. Nice. Now let's introduce scale variation. Drag from the scale input of Instance on Points and add another random value node. Change the data type to float. If it disconnects, plug the output back into the scale input. Set the min to 0.8 and the max to 1.2. Subtle size variation like this adds a surprising amount of realism. Finally, go back to Distribute Points on Faces and fine-tune distance min. Around 0.006 works well here. You can also slightly lower the pivot offset, around 0.003, so the sprinkles rotate more naturally around their center. Take a look now. They're lying down. They rotate randomly. They vary in size. They're not intersecting. That's a solid procedural scatter. Now go full screen for a moment and really observe the result. You'll notice something. Sprinkles are distributed everywhere, even underneath the icing. That's not convincing. Real donuts don't have perfectly even distribution. Some areas are packed, others are sparse. That irregularity is what makes them believable, so we're going to control that using weight paint. With the icing selected, switch back to the Layout workspace. Go to Object, Data Properties, and add a new vertex group. Rename it something clear, like Sprinkle Density. Now switch to Weight Paint mode. The mesh turns blue. Blue represents zero weight, no influence. Here's the idea. Weight paint allows us to paint values between 0 and 1 directly onto the mesh. Later, geometry nodes will read those values to control sprinkle density. Blue means no sprinkles. Red means full density. Everything in between creates a gradient. Make sure brush weight is set to 1 and strength is also at 1. Start painting red across the top center of the icing. That's typically where sprinkles collect the most. Work your way outward. Build variation. From this point on, the distribution is in your hands. You decide where it's dense and where it falls off. This is where technical setup meets artistic choice. Think about how sprinkles land in real life. They cluster, they miss spots, they build up toward the center. If you prefer heavier coverage on top, push more red there. If you want subtle fall-off near the edges, ease it back. Hold control while painting to subtract weight if you go too far. Avoid symmetry. Perfect balance usually looks artificial. Take your time here. Move around the model. Adjust as you go. This part isn't about precision, it's about observation. When it feels natural, it usually is. Alright, that looks good. Now head back to geometry nodes. Make sure you're in object mode. On the Distribute Points on Faces node, drag from Density Factor and add a named attribute node. In the name field, type Sprinkle, or whatever you named your vertex group. The name has to match exactly. As soon as you connect it, the distribution updates. Now the sprinkles follow your paint. Dense where it's red, gone where it's blue. That's already much more believable. One last thing, and this adds a lot of flexibility. Let's create variation between donuts. Duplicate the donut. Select the icing, then shift-select the donut base. Press Shift-D and move the copy along the Y-axis. Now we have 2 donuts. We don't want both of them to share the exact same sprinkle density, so we'll expose a parameter to the group input. Pick a value you'd like to control per object, for example, overall sprinkle density. Drag that input into the group input node to expose it. You'll now see that parameter in the Geometry Nodes modifier panel, which means each donut can have its own value. Set one donut to around 150 density. That's your Krispy Kreme for a moment. Set the other to 0. That's your clean glazed donut. Same node system, same structure, completely different results. That's the strength of geometry nodes. Once you understand the logic, you can build systems that are reusable, adjustable, and production ready. Before we wrap up, let's step back and look at the full workflow. Not just what we did, but why it works. Because this setup isn't about randomly adding nodes and connecting wires. It's about how information flows. Everything begins with group input. That node represents the icing exactly as it exists in the scene. Untouched. No manipulation. It's the foundation. From there, the geometry flows into distribute points on faces. This is where the mindset shifts. We stop thinking in terms of meshes and start thinking in terms of points. The surface becomes a field of potential. Each point is not a sprinkle yet. It's a placeholder, a location waiting to become something. When we switch to Poisson disc, the distribution becomes controlled. Points respect spacing. They maintain distance. That single decision is what prevents chaos and creates believable scatter. Then density stops being a static value. Through the named attribute node, the system reads the vertex group painted directly onto the icing. Now the surface drives the distribution. Red areas produce clusters, blue areas stay clean. The mesh itself influences the result. That's where art direction enters the system. Once the points are defined, the workflow shifts from where to what. The collection info node brings in our sprinkle models. By instancing them, Blender keeps everything lightweight, even with hundreds of pieces. Instance on points replaces every point with a sprinkle from the collection. Each instance inherits position, orientation, and scale from the surface. Then we introduce variation. A random value node controls scale, subtle differences that break repetition. Another random value feeds into rotate instances, adding rotation in local space, so each sprinkle turns independently. And because we pass the surface rotation forward, the sprinkles sit naturally on the glaze. They feel grounded. Up to this stage, everything is still procedural instances. Before the final output, the system runs through realize instances. This converts the instances into real geometry. Now they respond fully to shading, lighting, and rendering. Finally, join geometry merges the original icing with the generated sprinkles. Nothing replaces the base mesh. It's all combined into a single result. And group output delivers the finished surface. It looks handcrafted, but it's driven entirely by structure and logic. This isn't just about sprinkles. This is procedural modeling for detail, for variation, for control. And once this clicks, you can apply the same thinking to anything: foliage, debris, surface breakup, even complex environmental systems. That wraps up sprinkles and our introduction to geometry nodes. Nice work. Next, we need something for the donut to sit on. Go back to the layout workspace. First, let's reset the 3D cursor to the origin. Go to the Object menu, Snap, Cursor to World Origin. Just for a moment, we'll remove one of the donuts. We'll bring it back shortly. Working with fewer objects makes positioning cleaner and faster. Select the icing, then Shift-select the donut base and press X to delete. Now we're working with a single donut, much easier to manage. Press Shift-A, go to Mesh, and add a plane. If something strange happens and the plane appears inside the sprinkles collection, that means the collection was active. Geometry nodes will read anything in that collection as potential instances, so delete the plane. In the outliner, select the default collection so the plane goes there instead. Now again, Shift-A, Mesh, Plane. Press S and scale it up so the donut has plenty of room around it. Think of this as our countertop or tabletop surface. Scale it up a bit more, just enough to frame the composition comfortably. Now let's place the donut on the surface. If you select the donut base and move it upward, you'll notice something immediately. The icing stays behind. That separation isn't correct. We need the icing to follow the base. This is where parenting comes in. Parenting allows one object to inherit the transform of another. It keeps related objects connected and organized. Here's the correct order. First, select the icing. Then hold Shift and select the donut base last. Selection order matters. The last selected object becomes the parent. Now press Ctrl P and choose Keep Transform. Good. Now move the donut. Press G, then Z, and raise it until it rests on the countertop. The icing follows perfectly. No separation, everything stays aligned. That's exactly what we want. Now let's model the ceramic plate. Before modeling, it helps to load a reference image. Even for simple objects, a visual reference keeps proportions accurate. Move your cursor to the top edge of the viewport until you see the double arrow icon. Right-click and choose Vertical Split. In the new panel, change the editor type from 3D Viewport to Image Editor. Now open your plate reference image. The plate itself is actually very simple to model, but here I want to demonstrate how to load and use reference images while modeling. This becomes extremely important when you're working with more complex objects, where accurate visual guidance makes a big difference. And by the way, if you want to use the exact same reference image, you can find the download link in the video description. Alright, let's build it. Press Shift-A, go to Mesh and add a circle. In the Settings panel, set the vertices to 100. Increase the radius to about 2.3. This gives us a smooth circular base without unnecessary density. Enter Edit mode and switch to Vertex Select. Press E, then Z, and extrude upward slightly to create the beginning of the plate's rim. Press S and scale outward just a bit to suggest that subtle outward curve. Once that shape feels right, select the bottom edge loop and press F to fill it. Good. Now let's soften the sharp transition. Press Ctrl B to bevel, scroll the mouse wheel to add segments, and pull it outward near the lip. That instantly removes the hard edge and gives it a more ceramic feel. Next, we'll give the plate thickness. Switch back to Object mode. Go to the Modifiers tab and add a Solidify modifier. Set the offset to 1. Set the thickness to 0.006, just enough to make it solid without feeling heavy. Apply the modifier. Now let's refine the outer rim. Go back to Edit mode and switch to Edge Select. Select one edge loop. Then hold Alt-Shift and select the second edge loop. Press Ctrl B again to bevel. Now press C to enable Clamp Overlap. This is important. Clamp Overlap prevents geometry from intersecting itself. It limits the bevel when edges begin to meet. Click to confirm. Nice. The form feels much cleaner. We can close the reference panel now. Right-click on the divider and choose Join Right. One final cleanup step. When using Clamp Overlap, Blender sometimes leaves overlapping vertices. You won't see them, but they're there. Go into Edit mode, press A to select everything. Press M and choose Merge by Distance. Blender will now find and remove any duplicated vertices. You see 100 overlapped vertices are removed. Now smooth the plate. Switch to Object mode, right-click and choose Shade Smooth. Much better. If the bottom of the plate slightly intersects the countertop, move it up just a little. This prevents rendering artifacts later. I let the donut rest on the plate. The proportions feel balanced. The topology is clean. Nice work. In the next part, we'll move into materials and textures, refining the icing, the sprinkles, the ceramic plate, and the countertop to bring the entire scene together. I'll see you in the next part.